Remember? Can anybody explain what's going on in this simple diagram? Okay, I heard Diana volunteered. told to explain.
So like when you're dividing something, it's pretty much saying, like, I'm subtracting this amount
Repeatedly.
so many times.
Exactly. Yeah.
And then it's like the opposite for multiplication where you're adding something so many times.
There we go. Yeah, so repeated addition and repeated subtraction. So we can do repeated addition, then you can change that to just multiplication. If you are repeated subtracting something, repeatedly subtracting something, you can do division instead, right? We can see the relationship there. What's the relationship between plus and minus? Addition and subtraction. They are inverse to each other. We just use that opposite, right? They are inverse to each other. So they are additive inverse. These two, multiplication and division, are multiplicative inverse. Okay? So we know the relationship there. So we did models like set model, partition models, and some problems are not easy to do partition. So I want you to have a smaller number for that. And we also talked about mixing factor model, and we really help. I mean, we can use the relationship between multiplication and division when we do missing factor there. And we also talked about the terminology there, the number that is divided. So the first number is dividend. The number that is dividing is called the divisor, and the answer is quotient if there's no remainder, right? We also know the relationship between those three numbers. So how can we find the dividend? You can multiply quotient by the divisor, right? And the remainder is 0, just add 0. It's the same thing. If there is a remainder, you can just add the remainder to get the dividend. Remember that? Okay. And we also know that the remainder cannot be greater than the divisor, right? It has to be smaller. Okay, so we talked all about that. And let's move on to, we also talked about division by 0 and 1. Whenever you are dividing that by 0, it is always divided by 0. It's always undefined. But if your dividend is 0, what's the quotient? 0. It's always 0. There we go. If you are dividing by 1, so if your divisor is 1, what's the quotient? Same as the dividend, right? Itself. All right, so let's talk about the algorithm now. Let's talk about the algorithm. So again, for the algorithm, I want you to start with the manipulatives, like base 10 blocks, right? We have done that a lot. And because I need to teach with my online students, oh, where's my pen? Here we go. I found this virtual manipulatives, okay? So let's do some division there. What's the number here? 726 divided by 6. Let's see what's going on there. 726 divided by 6. What we're going to do here is we want to teach our students 726 divided by 6. So we want to represent this number using this 10 blocks here. Okay, how can I represent 700? Which one? What do I use? What do I use for 700?
700.
Which one is the 100? The flat here, right? So we can put 7 of them. 1, 2, 3. I wish I have a bigger column there. 4. These manipulatives are very useful, but still, I wish there are some more features that I can, adjust the sizes here because it doesn't fit in there. I tried different virtual manipulatives 2, but that flag was this big, I cannot put even 7 in it. So this is a little bit better, but I still think this needs to be a little bit more features though. Anyways, these one rod represents 110, so we need to have 20, 2 tens, and 6. The 6 of the ones. 2, 3, 4, 5, 6. So this shows 726, right? I can write 726 here. And we are dividing this by 6. What does that mean, dividing by 6? We are putting this into 6 groups. And we're going to see how many goes in each, right? So let's start from hundreds. We always do, in the algorithm, we always start from the left-hand side, right? So if I put 700 into 6 groups, how many does each group have? Let's see. I have 1 group, 2 groups, 3 groups, 4 groups, 5 groups, and 6 groups, right? I had a 6 groups, so all of these 6 flats are used. And in each group, how many do I have? How many flats? 1. So I can say, oh, I have 1 in each 6 groups, right? So all of these are used. How many did I use? I used 600. So you don't even have to think about that because you already did all of these, right? Now we see there's still 100 left. That's why we are doing the subtraction there, because we already dealt with these 6, right? So subtract 600, then I still have 100, right? The one that is left. But I cannot put any more, I cannot put this into, 6 groups yet, unless I switch this with 10 tens, right? So I can regroup this. I can regroup this into 10 of this. I'll just move this here, okay? Because breaking, it takes time, okay? But with your students, if you're using physical manipulatives, please regroup this with the 10 tens. Now I have 12 tens, don't I? Right? Because I broke these into the longs and I have 10 of them here instead of this. That's why we have 12 tens here, right? That's where you are bringing down these 2 tens. So now I have 12 tens. We still need to put these into 6 groups. And apparently we can do 2 bars in each group. 1 group, 2 groups, 3 groups, 4 groups, 5 groups, equally, and 6 groups. I have all 12 in 6 groups. And in each group, how many longs, how many tens do I have? 2 of them. So I can say, oh, 2 in each 6 groups. So I use all of those 12 tens. This is not just 12, it's 12 tens. That's why it is 120 actually, right? Okay, but we don't usually write that. With your students, you know that it is. Oh, darn it. How can I go back? Okay, anyways, we are done with that part and we have only 6 of them left here, right? Oh, that's really bad. Okay, so we have 700, 726 divided by 6, and we had hundreds in each. So we used all 600 and subtracted, and we got 12 tens. So we found it out. In each group, we have 2 longs, right? And we used all of those 10 rods. So now what do we have? Only 6 are left. That's why you are bringing down that 6 here. Okay? And we're gonna still put them in each of the 6 groups. So we have 1 group, 2 group, 3, 4, 5, 6 groups. So in each group, we see that, oh, only one of that ones go in. So we use all of that. And there is nothing left, right? Okay. So we can do, we can do diffusion algorithm using the base 10 blocks. Now we can see the close relationship between the blocks and the numbers here, right? Okay, here I want you to check your answer. How can we do that?
21 times 6.
Yeah, so the quotient times the divisor plus the remainder. In this case, we have nothing, so plus 0 has to be what? 726. There we go. So you can, do the multiplication here, and 6 times 1 is 6, 6 times 20 is 120, and 6 times 100 is 600, so it becomes 726. You can always check your answer. Okay? Okay, so that is the algorithm that you can do. Right? What's happening? We can also do partial quotient. Do you guys remember partial sum and partial product? We can also do the partial quotient with scaffolding. So for example, a shopkeeper is packaging microwave bags in cartons. That for the 32 bags each. So in one carton, you can put 32 popcorn bags. She has 4,224 popcorn bags. How many cartons does she need? We know how to do this division using the standard algorithm or repeated subtraction or partition. But let's think about partial quotient. So we know this situation we're gonna do 4,224 divided by 32, right? So I will show you how to do the partial quotient. Okay, so 4,224 divided by 32. I will actually rewrite that here. 4,224 divided by 32. So we can think about how many 32 goes in 4,200. How many? In 4,000, well, it's not gonna be fit in, right? So we're gonna look at the next two digits. 42, 2. Yes, 1, because 32 times 100 is equal to what? 3,200. So if we had only 100, I use all 3,200 popcorn bags, subtract it, and what is left? This, right? If we're gonna look at first digit, 32 doesn't go in 1, 32 doesn't go in 10, 32 can go in these three digits. So we're gonna take a look at that. 32 times what is close to 102? 3? Because 4 is too big, right? 4, then it's gonna be 12, which is too big for that. If we do 30, because it's we're gonna count how many tens there are, 102 tens. Then what is it? 960, right? So if we do 30 times 32, we are using 960. So what is left? 4, and we don't have enough, so we need to regroup that, but there's nothing, so we are regrouping this with 10 tens. We still need to regroup this, want to give 1 10 there, and there's a 900 left. So 12 minus 60 is 6, 9 minus 9 is nothing, right? So 64. How many 64? How many 32 goes into 64? Total? Yes, which is 64. So we know that 32 times 2 is 64, and you use them all. There's no remainder. So these are the partial quotient. Then the final quotient should be, you just add them together, 132. You can say that the answer is 132. That is a partial quotient. So I think it's a little bit more understandable because we are breaking down into smaller pieces. Right? Does this make sense? Partial quotient? Okay. Then try this one. There are 3 seats in each row of an airplane for passengers. If there are 63 people moving the airplane, how many rows of seats are needed for the passengers? When you're solving this problem, I want you to think about at least 2 different ways. Okay, at least 2 different ways. You can use repeated subtraction, you can use partial quotient, you can do standard algorithm, you can also do partitioning, right? So think about all the possible ways to teach your students with this problem. And I will ask your strategy. So there are 3 seats in a row. That's very small plane, isn't it? Can a plane have only 3 seats? A problem like this, I don't like it because in the real life, you don't have that kind of situation much, right? Can we actually change this to be more realistic? Let's do that. So instead of 3 seats, let's have how many seats? Usually 2 and 2 and 3 in the middle. I mean, it's kind of normal size, isn't it? Or you wanna do 2 and 2? A little bit bigger seats than this. Okay, so 4 seats in a row. How about that? If you have 4 seats in a row, and there are, let's say, 163 people who wants to go in this plane, how many rows of seats are needed for the passengers? My question is, how many rows are needed in this airplane? Okay, I want to hear as many as possible strategies. So let's go with Gavin. Gavin, what's your strategy?
The partial.
Partial quotient? So tell me how we can do by 4, right? No,
Yeah.
what?
So start with 160.
Uh-huh.
It's 4.
4 times 40 is 160. And you subtract it, and what do you get? 3. Here we cannot do any further, right? Because 40 is the only one, and the remainder is 3. So how many seats, how many rows do you need then? 40 or 41?
Have 40 rows.
We want to put all the people there. Yes, Lindsay, can you say that out
You
loud?
have 40 rows with 4 seats in it, and then you have 4 rows.
One more row, right? Yeah. Even if it's not full, we need to have one more row, right? Yeah, so actually for this case, we need 41 rows. Right? Okay, very good. So sometime later, I think I'm gonna talk about that too, but you need to think about the remainder a little bit more carefully because sometimes some questions will say, like this one, you need to add that to the quotient in 41, but sometimes you need to drop it, and sometimes you need to have an exact number there. So next time I'm gonna bring that questions for you. Okay, so that is, let's suppose, okay, can we change the problem a little bit bigger, like 1,163, so we can actually do the partial quotient there? Okay, so sorry about that. We're gonna change the problem because I actually want to do that partial product. Okay, so Gavin, let's do that again. We have 1,163 people. Okay, divided by 3. How can I do the partial quotient?
If you start with the 1,000.
Thousands. Okay, here. but it's too small, right? So we can look at next digit, 2 digits. So what goes in, how many 4 goes into 11? 4 times 2 is 8, 4 times 3 is 12, which is too big, so 200, okay? And 200 is, times 4 is 800, then what is left? 363, right? Then we can see how many goes in the first digit. 4 doesn't go in 3, so we need to look at 2 digits. 36, how many 4s go into the 36 tens? 9 tens. 4 times 9 is 36. We do that 3, right? So that's 360. Then there is only 3 left. So nothing on the ones place, right? So what is the quotient then? These are the partial quotient. 290. And the remainder is 3, right? So in this case, how many rows are needed? 291 rows. Right? Very good. So that is a partial quotient. And Lindsay, how did you solve this problem?
I did the,
Standard
Standard
algorithm?
algorithm.
Okay, let's do standard algorithm. 1163. Maybe everybody tried the standard algorithm as one of the strategies. Isn't it? Flo, did you do standard algorithm? Okay. So Lindsay, tell me what I need to do. It's very similar, right?
yeah,
The 4 times 2 will be 8, and subtract, and you get 360, and you do 4 times 9, 36. So this is actually 3610, right? And then drop 3 down because that is remaining. And there's nothing goes in the ones place. It's gonna be 290, right? That's standard algorithm. If I do repeated subtraction, what can I do? We need to just continuously subtract 4. Or how many times? 209 times. That's very tedious. So we don't want to do that, right? Okay. Simple partial product. Well, you can make 4 sets and you're gonna keep putting the person there. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's tedious too. So either these two should be good with big numbers like that. Okay, I think we are good on this. So let's move on. Mental computation and estimation. So we have done this a lot for addition, subtraction, and multiplication, right? So we kind of know what we are supposed to do. So mental computation for division, you can breaking up the division. That's what we do a lot of times, right? So for example here, okay, no pencil. Okay, just take a look at this problem up here. And we see that, oh, 7 times 6 is 42, and 7 times 8 is 56. But that 42 is not actually 42, but it's 4200. So we can say that, oh, 600 goes into 4200. And there's 56 left. How many 7 goes in? 8 goes in. So we have 600 and 8 goes in 4,256, right? So that's breaking up dividend. You can also use comparable numbers. So for 100 divided by 3, we know that 3 times 30 is 90. So we're kind of breaking up to here because we know the easy number for multiple of 3. So 3 times 30 is 90, and 3 times 5 is 15, right? So we can add those two as quotients. Does this make sense? Yeah, similarly, we can do the division here too. I mean, subtraction there too. That one I want to explain that to you. look at this one again. So to make it easier using comparable numbers, I know that 3 times 30 is 90, and 3 times 5 is 15. And I can easily change 105 as 90 plus 15. It's the same amount. So nothing has changed, right? So 3 times 30 is 90. We are good. And for 15, 3 times 5 is 15. So it's good. We know that the quotient is 30 plus 5, 35. Let's take a look at this. It's a little bit different because what we are gonna do here is subtraction. Because 8 times 40, 8 times 40 is, let's see, 320. 8 times 30 is 240. It's very close to this one, right? So let's use that number instead, 240. It's not exactly the same. So to make it equal, we can take away 8. And it's good because both numbers here, 240 and 8, are divisible by 8, right? So take a look. 240 divided by 8 is 30. We got it. And 8 divided by 8 is 1. So 8 times 30 is 240, and 8 times 1 is 8. But the relationship between those two numbers is subtraction. So what do we do with these two quotients? We also need to subtract them. So the answer is 29. This is pretty cool. Don't you think? So let me give you one example. Let's do 809. 819 divided by 9. Do them mentally. You don't need anything on your pencil, okay? Try to do this one first, and then I want you to think about okay, let's do both of this. You got that already in your mind? Yeah, mentally you can do it. Okay, so let me have a guidance here. For this one, who wants to go? How about Hannah? Mentally. Louder, I cannot hear you.
Sorry, 81 divided by 9 is
Uh-huh.
9 divided by 1.
Yeah, so kind of this. 81 is 810 plus 9, right? So you did 9 times 9 is 810, and 9 times 1 is 9. So you can find it, right? Very good. How about this one? Anybody here? Regan?
I kind of did 900 minus 9.
You guys agree? Yeah, 900 minus 9 is 891. So we can separate this, right? Very good. So 9 times 100 is 900, and 9 times 1 is 9. What's the relationship in between? Minus. So the quotient should be 99. It's so much easier than just do 891 divided by 9, right? So using the comparable number, it's very powerful. Good job. Okay. This is also making comparable numbers too. So, this is estimation. So instead of dividing 4,163 by 5, you can change this number to a close number, 4,000, because it's so much easier to divide it by 5. However, you need to think about whether you overestimated or underestimated. Okay? So we did 4,000 divided by 5 instead of 4,163 divided by 5. So how much we have has increased or it's decreased? From 4,163, we changed that to 4,000. So did we decrease or increase? We decreased the amount we had at the beginning. But we are not changing the divisor, right? So each person, so we are dividing this 4,163 to 5 people. Now we have 4,000 dividing that by 5 people. And how much does each person get? They are similar, but since we reduce the total amount, how much they get will be actually less than actual number, right? So when we decrease the dividend, the quotient will be smaller too. So we underestimated, right? Actual value, actual quotient should be a little bit bigger than 800, but it has to be very close to 800, right? Does it make sense? So always use your number sense for that. Okay, now try this. Everyone, in your notebook or in your head, estimate the following mentally. Oh, it says mentally, and explain the answer. Flyers are to be delivered to 3,625 houses, and there are 42 people who will be doing the distribution. If distributed equally, approximately how many houses will each person visit? Okay, this is similar to newspaper delivery. Once you find it, you can also talk with your neighbor about your thinking. Okay, so let me restate this. So there are 3,625 flyers and 42 people are delivering that to houses. They want to do that equally, right? But you need to figure it out about how many flyers each person have to deliver. So how many houses they have to visit. So we're gonna do this mentally. How would you do that? Tell me.
I rounded the 3,625 to just 40,600.
So 4,000?
You could do it that way too.
Oh, what did you say?
I did it to 3,600
Oh, 3,600.
and then changed 42 to 40.
To 40. So let's take a look at this. So she decreased the number of flyers and she also decreased the divider. So if both of them are decreased, it's kind of even out. So I like this strategy. If we do 3,600 divided by 40, you can drop that zeros and put that back in later, right? So 360 divided by 9 and 4 is 90. So about 90 houses. I like this strategy. Or maybe you can also think about changing this to 4,000 and changing this to 40. What happens this time? I increased number of flyers and I decreased number of divider. Then what happens? Am I overestimating or underestimating? I am overestimating, right? So how many is divided? If this goes big, then the quotient will go big, right? Also, this will go, the divisor will go down. Then again, this goes up, right? So I kind of double increase for both. So I am overestimating in this case. So I kind of like this one better because I'm evening out. One, you can decrease this number, but you can, you can, decrease this number and you can decrease this number. So let's think about this one more time. Okay, so we have the dividend, and we have a divisor here. If we increase the dividend, what happened to the quotient? It's increasing too. If we increase the divisor, what happens to the quotient? It goes down. Because think about number of people that are distributed, right? So we have this much pizza. If we divide this by 5 people, compare that to distributed by 10 people, we get smaller number there. So if the divisor goes bigger, the quotient goes smaller, right? So we can kind of use our number sense for that. All right. That's really nice. Okay, so the last thing we're gonna do is order of operation. What do you know about order of operation, guys? Order of operation. So when you're operating something like addition, subtraction, multiplication, whatever operation, there is an order. So what order do we have? How do you remember? Okay. PEMDAS. Some of you are remembering that as a PEMDAS. Maybe some of you are remembering this as please excuse my dear Aunt Sally. Is there anything else that you remember that as? Maybe basically those two. Okay. The thing here is what we need to be careful here is these, right? Why? Because multiplication doesn't always come before division. Addition doesn't always come before subtraction. So these two are kind of parentheses. Whichever comes first. So from left to right, you need to operate that first. Okay? So let's have some examples. Let's suppose, let's solve this problem. What do I need to do first? Parentheses. What is the parentheses here? So I'm gonna operate inside of parentheses first. Inside of parentheses, I have two things. Square, right? That's exponent, and I also have addition. So what do I need to do first? Exponent. So I need to do 25 first, then add that by 3 in this. Right, so I'm gonna rewrite that as minus 25 plus 3. You see, plus 5, right? And still, I'm not done with the parentheses, so I'm going to add these two together and I get 28. And the parenthesis is gone, right? All right, now we have subtraction and addition. What do I need to do first? From left to right. Bingo. So we need to do this first, right? So 12 minus 28, negative. Oh, you didn't do the integer yet, right? So you know that. This is gonna be negative number. It's same as 28 minus 12, negative. So 16 plus 5. That would be negative 11. Something like that. Okay. So yeah, that's it. So let's see if I have any example for you to solve. So here, parentheses, exponents, multiplication or division, always left to right. And the fourth is addition or subtraction from left to right. Can you solve this one too? In the paper? 6 times 4 divided by 12 plus 72 divided by 8 minus 9. And I will call out your name to help me out. Chantal, can you join us? Yeah, unmute and tell me what I need to do. Chantal, unmute.
Oh, sorry.
That's fine. Okay, tell me what I need to do.
So 6 times 4 is 24.
24. So 24 divided by 12 plus 72 divided by 8 minus 9. Then what?
And then I went 24 divided by 12 and 72 divided by 8,
Hmm?
which is 2.
2.
And then I got, 9.
Minus 9, right? So we can do 2 plus 9, which is
11.
minus 9 is 2, right? So you can do it. Let me ask you one question. Can I do this one before I add them by 2? Can I?
Technically, no, but in this case, it still works out.
It works. Why does it work?
9 minus 9 is 0 and 2 plus 0 is 2.
Yeah, and think about the subtraction, the definition of subtraction. What did I tell you about it? It's addition of negative number, right? So this is actually same as 2 plus 9 plus negative 9. It's same thing. And look, we have addition and addition. What can I do here? I can use any kind of property there. I can use associative property. So I can use that associative property and do that operation before you add it by 2. That's why it works. Okay? All right, great job, guys. Let's see. Yeah. So quiz 2 is also homework, right? For this weekend. Let's see. Section 3.5 homework and quiz 2 homework there. And then we are done with this chapter. Can you believe that? So your first review homework and test is coming up. So on Monday and Wednesday, both of those days, we are meeting in the computer lab. Okay? So basically, on the 13th Monday, you're gonna work on your chapter 3 review homework there. And you can ask me any question. This is good opportunity for you to review chapter 3. So when you are solving the problems on chapter review homework, you need to have that as a learning opportunity. Okay? And again, thank you so much for doing that volunteer work at the school. And please make sure you write the log precisely, okay? Put as much as you can put in there. If you have any questions, please let me know. And have a great weekend, guys.